Welcome to Session 4 of the Osher Lifelong Learning Institute course on maintaining optimum brain health and fitness. I'm your peer leader, Len Matheson. This is the fourth of 5 sessions. We're developing 5 useful tools to help you maintain optimum brain health and fitness. In this section, we're going to focus on exercise and nutrition for brain-body homeostasis. Today we're going to look at how exercise and nutrition support brain health and fitness. Let's take a look back at what we mean by brain-body homeostasis. Homeostasis has to do with balance. To maintain health, you have to maintain balance. The balance between your brain and your body is very complex. It can be thrown off easily. And in this course, we've talked about how the brain and body are integrated. We think of the brain as being in control, and now that many of us are retired, we'd like to have our homeostatic balance be something we can do like this. Swinging away, moving on into older adulthood for the rest of our lives, just enjoying life. We've gotten off our unicycle, we've taken all the juggling things that we've had to handle and put them aside. But what if homeostatic balance required that we stay on our unicycle, that we stay fit, that we stay engaged to some degree? And that's actually what the science shows. That's what we're going to be addressing today. To the degree that as we get older, our homeostatic balance is more difficult to maintain, most of the tools that help us maintain it have to do with staying engaged and active and participating in demanding tasks. So let's get into it.
What if I told you there was something that you can do right now that would have an immediate positive benefit for your brain, including your mood and your focus? And what if I told you that same thing could actually last a long time and protect your brain from different conditions like depression, Alzheimer's disease, or dementia? Would you do it? Yes. I am talking about the powerful effects of physical activity that is simply moving your body has immediate, long-lasting, and protective benefits for your brain, and that can last for the rest of your life. And so now, after several years of really focusing on this question, I've come to the following conclusion: that exercise is the most transformative thing that you can do for your brain today for the following 3 reasons. Number 1, it has immediate effects on your brain. A single workout that you do will immediately increase levels of neurotransmitters like dopamine, serotonin, and noradrenaline. That is going to increase your mood right after that workout, exactly what I was feeling. My lab showed that a single workout can improve your ability to shift and focus attention, and that focus improvement will last for at least 2 hours. Let's start with my favorite brain area, the hippocampus. The hippocampus, or exercise, actually produces brand new brain cells in the hippocampus that actually increase its volume, as well as improve your long-term memory, okay? And that including in you and me. Number 2, the most common finding in neuroscience studies looking at the effects of exercise, long-term exercise, is improved attention function dependent on your prefrontal cortex. You not only get better focus and attention, but the volume of the hippocampus increases as well. And finally, you not only get immediate effects of mood with exercise, but those last for a long time. So you get long-lasting increases in those good mood neurotransmitters. But really, the most transformative thing that exercise will do is its protective effects on your brain. Here you can think about the brain like a muscle. The more you're working out, the bigger and stronger your hippocampus and prefrontal cortex gets. Why is that important? Because the prefrontal cortex and the hippocampus are the 2 areas that are most susceptible to neurodegenerative diseases and normal cognitive decline in aging. So with increased exercise over your lifetime, you're not going to cure dementia or Alzheimer's disease. But what you're going to do is you're going to create the strongest, biggest hippocampus and prefrontal cortex, so it takes longer for these diseases to actually have an effect. The rule of thumb is you want to get 3 to 4 times a week exercise, minimum 30 minutes an exercise session, and you want to get aerobic exercise in. That is, get your heart rate up.
In this paper that Dr. Suzuki did with her student Julia Basso, they reviewed hundreds of studies to identify the effects of acute exercise on mood, cognition, neurophysiology, and neurochemical pathways. Basically, what they found was that a single bout of exercise, one bout of exercise, can enhance attention, mood, and stress resistance in normal populations. And the focus we're going to take today is not on mood or stress resistance, but it's on attention. I'm going to share some stuff with you later today that's really going to shake you up, that's going to cause you to expand how you look at our brain-body interaction to address serious problems that people have. The example I'm going to give you is Parkinson's disease. But let's take a look at what their findings reveal. This is a table in one of the studies that I've provided to you as a PDF. We're not going to go through all of this, just a couple of high points. One of those is that GABA, gamma-aminobutyric acid, which is a neurotransmitter that decreases your irritability and emotional tension and increases your sense of calm, will be increased for 20 minutes after one episode of exercise. Serotonin, a neurotransmitter that improves your sleep and mood and helps you feel calm, will be increased for 120 minutes or more after one bout of exercise. Norepinephrine, which increases your energy and helps your memory and gives you pleasure, will be increased for about 75 minutes after one bout of exercise. Dopamine, which fuels your pleasure circuits and is crucial for cognitive processing, will be increased for about 120 minutes after one bout of exercise. And your endogenous opioids that are manufactured in your brain to provide pain relief will be increased and will stay at an elevated level for about 30 minutes after exercise. And then finally, BDNF, brain-derived neurotrophic factor, also known as Miracle-Grow for your brain, which encourages the development of new synapses and is crucial for learning and memory, will be substantially increased for about 90 minutes after exercise. So you buy an awful lot with exercise, don't you? And this is just one bout of exercise. So if you were to do one bout of, let's say, 30 minutes of exercise every other day, you'd have these positive effects in terms of your neurochemistry on an ongoing basis. Your body would gradually adapt to that. Problems like depression, anxiety, and several of the age-related disorders are wonderfully addressed by exercise. So Dr. Basso and Dr. Suzuki have identified this in normal populations, but how about in populations of people who already have pretty serious problems? How about a person who's had a stroke? Let's take a look.
Music is therapy for 55-year-old Bill Forrester.
I don't want to say I'm an artist, but I love the arts.
About 4 years ago, Bill suffered a massive stroke on the left side of his brain. Initially, it robbed him of his ability to walk and talk, and recovery looked grim.
The doctor, she said, Bill is lost.
Bill was far from lost, but he felt trapped inside, struggling with aphasia, where you know what you want to say, but you can't get it out.
One less. I was a public speaker before. I love talking.
Speech therapy helped bring words back, and then Bill turned to music therapy to find his voice.
Lisa helped me for my diaphragm to exercise it.
His voice just sounded more natural when he was talking. It just sounded like Bill again.
During their sessions, Bill's music therapist uses music, lyrics, and instruments.
The primary thing we do is work on his speech through singing songs, and then we also do some fine motor with him playing the keyboard and the guitar.
Recent research from Cleveland Clinic shows that music therapy may help restore speech in some people who have recently suffered a stroke.
Language is on the left, music is on the right. So the music can be used to help retrain the left side of the brain.
Bill has already surpassed everyone's expectations. The man who would never walk or talk again is now running marathons and teaching, and he doesn't plan to stop there.
I want my life again. I will be whole again.
At Cleveland Clinic, I'm Erica Foreman.
So how can we apply this to Parkinson's disease? Parkinson's disease, or Parkinson disease, occurs because of decrements in performance in what's called the substantia nigra, deep in the brain around what's known as the red nucleus. As part of the reticular formation, the substantia nigra produces dopamine, and dopamine is a crucial neurochemical for many brain activities. In Parkinson disease, the decreases in dopamine are demonstrated by problems with walking, problems with balance, eventually problems with cognitive function. The first effective methods to treat Parkinson's disease revolved around the availability of dopamine and medications that could be used to promote the availability and release of dopamine. More recently, surgery to implant electrodes in these areas has demonstrated a high level of efficacy for treatment of Parkinson's disease. But are there additional methods? Well, let's take a look at this. A recent international study in the journal JAMA Neurology provided a review of compensation strategies for gait impairments in Parkinson's disease. But I want to caution you. This is not something that can be done by an individual with Parkinson's disease on their own, not safely anyway. The caution provided by the authors must be heeded. All patients with PD should be educated about the available compensation strategies, and together with an experienced therapist, the optimal compensation strategies for that specific individual should be identified. And let's emphasize that this is done together with an experienced therapist. And the reason for that will become obvious when you view the video. Now, this video has been withdrawn from YouTube. I don't know the reasons for that, but I think it was wise. What you'll see in the video are people with Parkinson's disease doing things that are very dangerous. Now, they're doing them successfully, but the potential for injury is great, and that's why it needs to be done with an experienced therapist. The point of the study and the point of the video can be summed up in this quote from the paper. The overarching working mechanisms involve an allocation of attention to gait, the introduction of goal-directedness, and the use of motor programs that are less automatized than those used for normal walking. The focus is the allocation of attention to gait, and the reason that has been hypothesized takes us back to the substantia nigra. Parts of the substantia nigra are closely linked to the parts of the brain that have to do with maintaining attention. And so the thinking is that to the degree that a person with PD focuses attention on a task, such as you will see in the video, their performance greatly improves, apparently to the point where they're safe once again doing tasks that would otherwise be extremely dangerous. At the end of today's video, I'll show you how to access the video from the JAMA network. But for now, let's loop back around to the work of Wendy Suzuki and her students. Remember, they taught us that a single bout of exercise can enhance attention, mood, and stress resistance in normal populations. And so what do we do with that? Well, we circle back around to just right challenges. In earlier classes, we've talked about just right challenges. We've defined those as meaningful tasks with difficulty that are just beyond our current ability. Just beyond our current ability and doable only if we put in extra effort. And here's a brief video that fits for me. Maybe it will be useful to you as well.
In this video, you will learn how to increase your walking speed. We will first suggest 2 ways of increasing your walking speed. Then an example practice session dedicated to working on your speed. To increase your walking speed, you can either increase the frequency of your steps or increase their length. Firstly, increasing the frequency of your steps. Increase the pace of your steps, making sure to roll through your feet and push off with your toes. This movement will use your lower leg muscles. So make sure to warm up beforehand by walking for a few minutes. Then by walking on your heels for a few meters. You use a pendulum movement in your arms to move forward, keeping them bent at a 90-degree angle and not letting your hands swing any higher than your chest. Adapt the frequency of your arms swinging to the cadence of your steps in order to ensure that your arms and legs are synchronized. Secondly, increase the length of your steps. To increase the length of your steps, push your foot further forward. To do so, increase the rotation in your hips. Also, extend your arms further when swinging to propel yourself further forward. When your arm goes backwards, slightly unfold it by reaching far behind you with your hand. When it comes forward, bend your arm at a 90-degree angle again, and try not to bring your hand higher than your chest. Don't be surprised, lengthening your stride makes you lose your breath. If you're too breathless, go back to the pace that suits you best.
And so as I get older and need to improve the coordination and connections between both of my cerebral hemispheres, to improve my balance, to improve my coordination, a task like this, in fact this very task, is what I'm going to take on every other day as a just right challenge, to be intentional about using my attention on a task that I've done automatically up to now. While I'm still going to take a walk in the park from time to time, this activity of fast walking is going to be my just right challenge to develop and maintain and protect optimum brain health and fitness. And what else will I need to do? Well, I'll need to be serious about my nutrition. And the approach I'd like to take in our talk today is on its psychobiology. The psychobiology of nutrition is very simple. What you eat and drink will either calm you down or make you anxious. Of course, it's much more complex than that, and a nutritionist is going to be much more detailed about the psychobiology of her work, but this is the core of it. What you eat and drink will either calm you down or make you anxious. So let's take a look at some of the neurochemicals that are most important and what we can do in terms of nutrition to support their development. We're going to go back to GABA. Remember that GABA decreases your irritability and emotional tension and increases your sense of calm. L-glutamine is the amino acid precursor that your body uses to produce GABA. These are the foods that help produce GABA: almonds, eggs, peaches, avocados, sunflower seeds, and peas. These are the top 6 for GABA. And how about serotonin, the neurotransmitter that improves your sleep and mood and helps you feel calm? Well, the amino acid precursor there is L-tryptophan. Your body uses this, most of it in your intestinal tract, to produce serotonin. And these are the foods that help produce serotonin: almonds again, turkey, milk, cottage cheese, soybeans, and pumpkin seeds. The big 6 for serotonin. And how about dopamine, the neurotransmitter that fuels your pleasure circuits and is crucial for cognitive processing? Tyrosine is the amino acid precursor that your body uses to produce dopamine. And what are the foods for that? Well, almonds don't show up here, but we've got beef, fish, chicken, oats, wheat, and soybeans as the big 6 for dopamine. And how about norepinephrine, also known as noradrenaline? This helps with our energy, our memory, and pleasure. L-phenylalanine is the amino acid precursor that your body uses to produce this neurochemical. And here we have almonds again as part of the big 6. Almonds, lima beans, sesame seeds, chicken, yogurt and milk, and soybeans. And what's the importance of vitamins? Well, B vitamins are necessary for the manufacture of those neurotransmitters. Two examples: B1 thiamine is necessary for GABA synthesis. B6 is necessary for the manufacture of dopamine. Foods that are rich in B1, here we go with almonds again. Almonds, peanuts, bran, vegetables, wheat, and brewer's yeast. And so to wrap up, let me give you our Optimum aging references for this week. Wendy Suzuki's TED Women Talk in 2018 is fabulous. Stick around for the end of that talk, stand up, get out of your chair, and follow Wendy's lead for the last minute of her talk, looking at the brain-changing benefits of exercise. She's brilliant, she's helpful. Another Optimum aging reference that we've talked about is the large study that was done internationally and published in JAMA Neurology, Compensation Strategies for Gait Impairments in Parkinson's Disease. This is no longer available on YouTube. The abstract is in the URL at the bottom of this screen. An easier way to access it is to go to Google Scholar and put in Nonnekes, the last name of the first author, Nonnekes, 2019. If you put that into Google Scholar, this reference will come up. You can download the PDF of this reference, and on the second page you'll see what you're seeing on the screen. At the bottom of the screen, you'll see a hot link to the multimedia that has to do with that video that we can't get through YouTube. It's still available to people who are brought to it by their serious interest in the neuroscience of Parkinson's disease. Remember, what you're going to see is dangerous for people with Parkinson's disease who aren't supervised. Let's not create more problems for these folks by inappropriate use of this video. And before we leave, here's what we're going to add next week to wrap up this course. We're going to look at community connectivity for high quality of life longevity. All of the class sessions up to this point are aiming at this outcome, high quality of life longevity. I look forward to seeing you next week. Take care now.